And hi and welcome back. So now we're on our next session of the wonderful DSL class here. Everybody having fun so far? Yay! There was much rejoicing. Yay! So what we're going to talk about today is Antler. Yay! It's pronounced Antler. This is another tool for language recognition. This is written by a guy named Terrence Parr, who originally started it off as a tool called PCCTS, the Purdue Compiler Construction Toolset. And the PCTS was written in C. I used it back in the 90s for my compiler class here to write my compiler. And it was pretty amazing what you could do with that compared to using like Lex and Yak. The amount of stuff that PCCTS has built in for doing symbol table manipulation and tree stuff was just fantastic. So it's like there's a lot of stuff that I could just say, hey, you do it for me, and it generated ASTs, and it was nice. The newer support is even better, but that was a great start. And then a little bit later in the 90s, he ended up converting it to Java just after Java came out, and that was Antler 2 was the first one. And actually, did he call it Antler the first time? I can't remember if it was Antler or Antler 2 when he first. I think it was Antler 2 because he wanted to have the 2 in there. And around then, I wrote a debugger for it that could basically let you step through your grammar and make a little nice outline of how things look. And so I got to be friends with him. Ended up working for him at Madgelang Institute, which, by the way, doesn't exist anymore. They were a company that we went around teaching Java to everybody. So, he hired a bunch of Java experts. We went around teaching it, had a lot of fun. The name, does anybody recognize that name? It's actually a city on the island of Java. And he came across it in a completely accidental way because he's a language guy with PCTS. And so he did a grep through the dictionary to find anything that had lang in it. And he says, ooh, Mage Lang. It's kind of like wizard's language. And then he looked up what it was, and it was this city on the island of Java. He's like, okay, you can't get any more perfect than that.
Probably not pronounced Mage Lang.
Magalang. It's actually Magalang. It's we always called it Mage Lang. And we had the coolest business cards. I got them in a drawer somewhere. It was a fun company to work for. They actually had on the back the little phrenology head type thing, and then some other little weird symbols and everything. It looked all. You ever seen that poster, Unix Magic? Oh. That one. It's kind of had that kind of feel going to it. It's kind of cool. Okay, so Tara wrote this tool, and it's now up to version 4, which has got some really nice support in it. Later on, we're going to take a look at something called Xtext, which builds on top of Antler to actually generate an IDE for you and generate models using EMF, which is a library inside Eclipse, the Eclipse modeling framework. It basically lets you specify meta models, so models for your models. It's models all the way down, that type of thing. This stuff we're going to deal with later on. Xtext is an absolutely fantastic tool, but it's pretty much bolted into Eclipse. Now, personally, I consider that a good thing unless you're forced to use IntelliJ. And then you have to do what I do, which is have Eclipse open with the base Eclipse version. Then that defines your plugins. Then you run a nested copy of Eclipse inside there to actually run your stuff and generate your code. Then you're running IntelliJ in a different window pointing to all the libraries in your Eclipse installation. So, it's a pain in the ass. Right now I'm working on converting some of the stuff that I'm doing for form generation in Android from Xtext to some internal DSLs in Kotlin. And that seems to be going pretty well. And the neat thing is the little language I'm using for the internal DSL is really similar to what I was doing in the external DSL. So it actually is making a fairly easy port for me. So anyway, back to where we're going to go today. Antler. This guy, let's see. Can I erase all this? There's no erase all on here. Nope. I wish there was a nice little erase all. At least I can use the eraser instead of having to flip it around. Is that an erase? No, it isn't. Okay. So, with Antler, start by defining a grammar. This describes your languages, and it has two sections to it. A lexer grammar and a parser grammar. And it takes this and generates a whole buttload of code for you. The code that it generates includes, surprise, surprise, a lexer and a parser. It also includes, if you ask it to, a parser-listener interface. And what this does, when you run that lexer and parser, the lexer takes your source code, pushes the results, well, takes the source code, reads the characters, figures out the words those characters mean, we call those tokens, and pushes them into something called a token stream. Token stream is basically a queue. So it's going to queue those guys up for the parser to gobble up. The parser is then going to read those tokens, and it's going to make sense of them, we call that semantic processing, to figure out the meaning of a sentence or the meaning of a phrase in your language. And that is going to produce whatever you want it to produce. By default, it produces what they call a parse tree. I'm not super keen on the use of the word parse tree there. I mean, it's fairly accurate. Parse tree generally was something that people think of in their head to describe how the parse proceeded, how everything got broken down. He actually realized it into a data structure. We used to just call it an AST, and there was a default AST generation which happened to look like the parse tree, but now he just said, screw it, I'm going to call it parse tree. So it generates this tree, which you can then listen to using your parser listener. And there's two ways you can listen to it. You can listen to it during the parse. So as we're walking through the file and recognizing things, it can fire off methods in your parser listener. Let me mute my phone here real quick. Okay. As you're walking through the parse, it can actually notify you saying, I'm seeing this, I'm seeing that, and then you can do whatever you want. The problem with doing it during the parse is sometimes you need information you don't yet have. In particular, for like this assignment coming up, when we have a direction, we have like south and then a component. I put those inside of a rule that I call direction. So it has those two pieces, south and component. You can get notified when it enters that direction rule, which is before it consumes that south token, or when you exit the rule, which is after you've processed everything in there, including the component. So at that point, I could either have said, well, let me wait and get the component sent to me and then I'll add it. What I really wanted to do is add the component at the point that I actually read the component in. So it's a little bit too early at the beginning, a little too late at the end. So a different way you can do this is, surprise, surprise, walk the tree after the parse. This interface is a visitor interface. And what we mean by that, let me, hello, how do I get this over to, oh, let's see. There we go. Create a new page. The idea of a visitor was a way to figure out what something is in a heterogeneous data structure without having any type of runtime type identification. And this was put in place to solve a limitation in C++ back in the 90s. C++ had no runtime type identification, so you couldn't ask an object, what are you? Of course, if you did, he would respond, I'm Batman. So with RTTI later on, you don't really need this. But the idea of the visitor pattern was you had a bunch of different types of nodes in a tree. Maybe this is another A over here, maybe that's a D. They can be of different types. It could be the same type. If they're all the same type, it's called a homogeneous data structure. But what we want to do is do something different at each of these nodes. So we have two main choices. We can put the what to do inside the data structure, and we've seen that with the composite pattern, right? But that means that there's exactly one thing that you can do with these nodes. And maybe you want to do more than one thing with it. Maybe you want to process it in different ways. Think about this parse tree, this abstract syntax tree we've gotten out of our parse. Maybe we want to run a type check against it first to say, hey, I've got two things on either side of an and. Are they both Boolean expressions? If not, boom, it throws an error. And then after I get past my type checking, maybe I want to run another pass on it to generate code. So putting it inside the data structure might not make the most sense. And if you happen to be generating this data structure, at the point of the generation, you probably don't know what people want to do with that code. So externalizing the idea of doing that walking is probably a good idea. So what we do is we have each of these guys basically sitting at the door waiting for somebody to knock. They all have a little method called visit. Now it doesn't have to be called visit, but the traditional pattern has the name visit for it, just to kind of make it obvious what's going on. And let's think about why we need this. If I had some kind of structure over here that said walk, taking in a node, and let's say all of these extended node. Inside this walk method, I couldn't say, for this kind of object, do one thing. For this other kind of object, do a different thing, back in C++ days. What I need was some way to know what the object actually is. So the idea behind the visitor pattern was actually kind of brilliant. They took advantage of something called double dispatch. And what they said is, I'm going to call a method in the object itself and have him call me back passing himself. By doing that, I can get compiler resolution and know exactly which method is being called. So I create over here a class or an interface, I'm going to call it visitor, with a whole bunch of methods here. I'm sorry, I got these wrong. These ones are usually called accept. I always do this when I'm talking about this pattern. There, I wrote it small enough that I don't have to actually write it. The accept method is going to take the visitor as an argument. And then what I do in the visitor is I have all these visit methods. And each of the visit methods takes a specific type. Kind of like that. Inside these methods, we know what the type is, right? It's going to, because that's what the parameter came in there. Over on this end, these accept methods all look exactly the same. So inside class A, I have accept visitor, and inside there, he says v.visit this. And every single class has that exact same accept method. When the compiler looks at it, he knows the type of this because it's inside the class, right? A, B, C, and so on. So the compiler can resolve that to say it's visit A. That's the visit that's going to get called at runtime. So by doing this little double dispatch, I call you and you call me right back, we end up getting the type of the object we want to deal with. Now, what kind of problems can this cause? Any ideas?
Well, I mean, if there's an inheritance in what you're passing around, I mean, what would you actually get back? Would you get back the parent class or the subclass?
So inheritance can be a real issue here. If you had, let's say, A and B were related, we're going to get the actual type A or B passed over, but let's say we add in class C, which extends A. Now if we don't change our visitor to include C, it's going to call visit A, right? So that's the best it can do. You get errors, you get issues kind of like that coming up there. If for some reason the inheritance hierarchies of these guys change, and maybe you weren't covering all the cases in your visitor, suddenly you can get different behavior out of that. That's not a good situation. What else is problematic with this? So, well, if you forgot to implement it, you probably get some kind of a compiler error because these guys are all calling each other's accepts to kind of trickle it down. But you could forget to implement it, or you could implement it incorrectly. What happens if you add a new type over here?
You would have to go and update the visitor.
So if I added X, I'd have to go and update my visitor, visit X, and then what happens? Here's where it gets really bad. Who's already implemented that visitor? You might not know. If I had a library where I defined all these types here, and I defined this visitor, and somebody else was implementing that to walk through my data structure, and then I add a type, their code's blown out of the water. That's when you start seeing people do things like visitor2 extends visitor to add in those new methods, and then somebody who only implements visitor1 only gets the certain subset of methods. And you end up with visitor2, visitor3, visitor4. It gets really ugly really fast. The API changes on this one are brutal. I mean, it's already hard enough to make sure you're versioning that such that things are forward compatible. But when you have something like this creates a huge nightmare for that. Okay, so this is the basic idea of the visitor. Does that make sense? Okay. And in the patterns class, I actually walked through several examples. I'm not going to get down in the details of how that's implemented. In general, I don't like this pattern. And the reason I don't like it is because it's really hard to conceptualize. I tend to explain it better than most people, but when you try to read it in a book, forget it. I mean, when I first tried learning this pattern, I was looking at the Gang of Four book, and my nose hit that page and at least 37 times when I was trying to figure out what that thing meant. It's brutal. Conceptually, I mean, once you get the hang of it, yeah, it makes some sense, but there's all sorts of issues here. I'd much rather use some kind of a runtime type identification if it's present. Okay, so let's come over here, create a new page. I think I've got a system going here. I can create new pages. Woo! Okay, so that visitor, once we have our parse tree, let's take a look at example what a parse tree might look like in Antler. Maybe I have a grammar. I'm going to make a real simple program, and a program has inside of it a type and maybe a main, and then I have type is going to be class ID, and maybe my main is main gren args gren curly brace, some stuff, close curly brace, and so on. So you kind of get a feeling for how we break this down into different rules describing the grammar of what we want to try to do here. Each one of these rules, program, type, main, args, whatever was actually inside the grammar there, is going to create a node in that parse tree. And each of those nodes is going to get a context object created for it automatically. And the context object has information about what was inside that rule. So, for example, this context object would have a type field and a main field in it. This context object down here would have two token fields there to keep track of the different tokens. And we can label these so we can actually pull them out easier later on. But for right now, I'm just going to kind of wave my hands and say it just has some token fields inside of it. So what we're going to get in our parse tree is a program node. Underneath him, we have a type node and a main node. Underneath the type node, we have, well, there's no separate rules. Underneath the main one, we have args and probably a body of some sort. Make sense so far? Antler, if you ask it, will generate that visitor interface for you. They call it a parse tree listener. And he has a enter and exit method for each one of these. So there'll be enter program, exit program. enter type, exit type, enter main, exit main, enter args, exit args, enter body, exit body, and so on. Passing in that context out. So when you say, hey, parse tree walker, walk my tree for me, it will call you each of those methods when you're entering and when you're exiting those nodes. If you do it during the parse, keep in mind that we might not have gotten the data yet. So when we come into the type rule, right at this point is where it's going to call that enter type. Over here is where it's going to call exit type. Similar for enter main and exit main. Make sense? The parts inside the rule may not have been processed at all. If we walk the tree after the parse is completely done, then that context has already been filled in with all the details. So you can then ask that stuff at the beginning or at the end, depending on what you want to do. Now for your assignment, you're probably going to want to take advantage of enter grid, exit grid, enter border, exit border, that type of thing. And what that'll do for you is at the enter border, you're going to push a new panel with the border layout on your stack. Your exit, pop it off, stuff like that. And then inside, when you see components, add them in to whatever the current layout is. Make sense? So let's see. Where else do I want to go with this before I actually start doing some code? So what we're going to do, we're going to use Gradle to set up our build for us. And unfortunately, with it being IntelliJ, things are not completely automatic. You're going to have to run your build a lot. Anytime you change your grammar, make sure you run that build. And make sure you're running the build and not that little arrow that's next to your main. Because if you try running the ones next to your main, it's not going to generate your grammar. And you're going to be pounding your head on a desk like, I just changed my grammar and I'm rebuilding. You're not actually rebuilding. You're just running the Kotlin stuff. So be careful about that. So inside there, a few things we have to do. We're going to have to add in an apply plugin, and we'll see these actually in Gradle in a minute here. We're going to have to add in a dependency for Antler. And we're going to have to say that the compile step for Kotlin depends on the grammar generation. Now, by default, the Antler plugin will set up a dependency between the compile step for Java and the grammar generation, so that you won't have to do anything special. But there's nothing baked in there for Kotlin. So because we're going to be using our grammar in Kotlin, we want to make sure that the grammar got generated, or generated its code, before we do our Kotlin compile. Make sense? So those are the three big things that we need here. We're also going to add in a run task to actually execute our application. So that's a good place to start. Put this aside for a minute. Uh-oh, just lost my power cord. Yeah, I don't want to run this thing on battery because it will last like 20 minutes, if that. Okay, so here is my wonderful new Antler project. I just built this as a Gradle project with Kotlin support, and I added a couple things in it. So the first thing I added was this line right here for apply plugin Antler. I also added this guy right here to say here's the Antler version 4 runtime that I want to use. Here's my guy saying compile Kotlin depends on generate grammar source. So this is going to make sure that I run generate grammar source before I try to do the Kotlin compile. And then finally, here's my little run where I'm going to be running a test here. And let me fix this guy up. We'll say com.javadude.antler1, and I'll say sample1. Why not? Okay, make sense so far? Now I've got this guy set up for auto import. Anytime I change this Gradle file, it automatically imports it back into IntelliJ. If you don't have that turned on, it'll put a little pop-up down here saying hey, you've changed your Gradle. Do you want to import changes now? Or do you want to turn on auto import? And I'd recommend turning on auto import unless you're doing a lot of work on the Gradle. If you're going to be doing like a whole bunch of new tasks, I'd turn off the auto import because otherwise it's going to try to keep building it and it's going to drive you insane. Okay, so we got him. Let's create a new Kotlin class here. I'm going to call it sample 1. And let's put some of the basics in there. That's the actual one. Let's go to this guy. And I didn't create a package. So here we've got a sample, and this code here I tend to call the Antler glue code. This is the stuff that's going to be setting up our Antler parser to run it. And the first thing we're going to want to do is set up a character stream, and this is an Antler character stream, not anything else. Think of it again as another little queue that the data gets read into to read some file. In this case, I said GUI layout 1. That's what you're going to use for your assignment. Let's call this expr1.expressions. Then we're going to create an instance of a lexer reading off of that stream. That's why we pass that input into it. So I'm going to say expression lexer. Then we're going to create a token stream, again another queue that the lexer pushes his tokens into. It's actually a pull, but just think about it as a push for right now. And the parser can then pull the tokens out of there. Make sense so far? This line here tells it generate that parse tree for me. Now you don't have to. I'm going to show you a couple different ways you can do this. I'm trying to decide if I want to tell you to do your assignment one way versus the other. I'm really on the fence on that. There's some huge trade-offs. I think that putting actions in the grammar, personally I find it a little cleaner. It's a lot harder to debug though. Doing it with the parse tree listener, you get to do all your code in Kotlin for it, and the grammar stays a lot cleaner. But there's a little bit more code there, and there's a little bit more separation on how the code works. By putting stuff into the grammar, you can actually pass things back and forth as arguments and return values from the rules. I'm going to show you both ways. I think I'm going to probably end up going the strong recommendation of doing it with the parse tree listener, just because it's so much easier to debug. And hopefully we will not see a lot of bug type problems while I'm going through this code here, because I haven't written this expression parser before. I did the assignment late last night and then all day today, and that seems to be working pretty well. And I did it both ways just to see what was going to happen with those two ways. So I'm hoping that I can fumble my way through an expression parser doing this for the first time. You get to see the fun. I've done so many parsers in Antler, it's not even funny. Okay, now this line here says run the start rule. And you can define any rule as a start rule. You could actually have multiple start rules if you wanted to. Maybe you have one that's for parsing a class and one for just parsing an interface. You could actually go in from different places there if you wanted to. But this will go through run the frame rule, which I'm going to change to be expression. And then this guy here is just going to dump out the contents. So it's going to look kind of like a Lisp string coming out. That's the way they represent things. This line at the bottom uses the parse listener after the parse has happened. If you wanted to use it before the parse, I could say parser dot. Come on.
You need another brace at the bottom.
Oh, yes. Oh, because I don't have any parsers. But you'll basically say add parser listener, passing him in there. And if you do that before the actual parse call, then it's going to actually run that thing while it's doing its parsing. I believe at this point, if you do it there, it won't try to hold the entire parse tree in memory. It'll only pass you the context that it knows at that certain situation. So it basically has a stack that it keeps track of them. I'm not positive on that. This one down here, obviously it has to walk the entire tree once it's done. This here, no, I mean, it's gonna return you the context at this level, so it's got to have all the information, so it's got to be the whole tree in memory. There might be a way to prevent it if you have a really huge file. I'm hoping that you're not trying to use this for really, really huge files. That's when, if you really have a big file, a better way to think about a DSL is to try to do it line-based, or delimiter-based, so you have small chunks you can look at a time, and read a small chunk and deal with it, read the next small chunk and deal with it, or even just lines and deal with it. That way you can just scan through the file as a stream, as opposed to pulling everything into memory. Okay, so this is our basic structure here. Let's go ahead and write our grammar. So I'm going to say new file. What did I want to call this one? Expressions.g4. And make that the expressions. There's a little bit of front matter. And so what we're going to do here is put a package in, com.javadude.antler1. Get those guys out of there. Don't need that. And what this is saying, at the top of every file I generate, stick in this package statement. So if you had a common package statement, if you had common imports you wanted at the top of your grammar and your parser, you could put it there. If you wanted it in just one or the other, you could say lexer, I think it's lexer : header, or parser : header. We'll include it just for the one or the other. Sometimes you might want to separate it. Most of the time, it's just the package name in there. Then we're going to have a set of rules. Any rule that starts in lowercase, that's a parser rule. Any rule that starts in uppercase, that's a lexer rule. And keep in mind that the lexer rules are meant to bring characters together to create tokens, parser rules, tokens together to create sentences. Let's start by writing a couple little lexer rules here. First of all, let's define what an ID is. And I'm just going to use a real simple ID here that's going to have letters and numbers in it. No underscores or any of that type of crap. So we're going to start with, I almost had the wrong syntax there. Oh, I didn't want that one. A ... Z or A ... Z. Boom. I have one letter. So this is giving me two ranges, lowercase letters and uppercase letters. So right now an ID can only be a single letter. If I wanted it to be one or more letters, bloop, I can do that. And now I can only allow letters in this. If I want numbers, it gets a little bit more complex. What I have to do is repeat this stuff here and add in 0 to 9 with a star, which is saying 0 or more. So this will allow me to have a single letter if I want to. If I want multiple characters, it has to start with a letter. Make sense? Yes?
Is the space between the two capture groups imply that there will be a space between the first letter?
No, it does not. So the question was, does that space between these two capture groups, this guy right here, imply anything? And no, it does not. Okay. And try not to think of these as capture groups. Because if you're used to regular expressions, then you're used to things in parens being capture groups. These are what are called alternations. So you basically have different alternatives that you can choose between. And I have to throw a semicolon in there. So this guy should match a single letter or multiple letters, possibly numbers after the first letter. Make sense? Now, if we wanted to have it restrict to has to always start in lowercase, I'd get rid of that or capital A to capital Z stuff in there. Let's create a little parser rule here. Things. And I'm going to say things. Let's say that you have to type in 3 IDs. Boom. Something like that. Nice and simple. I'm going to go over to my Gradle builds and take a look underneath other, and I'm going to say run test 1. Now it's going to die, but I'm just going to use that as a starting point here. So there's my generate grammar source being run. Something went wrong. So actually it got down to the compile of the Kotlin and said, hey, I don't know all this stuff. So let's go ahead and fix that up. And why is he not coming up there? So we had build, generated source, antler, main, com, java dude, antler 1, blip, blip, blip. So it's not seeing that as... Half the time it seems like I have to add him into my source set explicitly. Let me try this. Gradle W. Clean. Build. Okay, that seems fair. So this is from Antler. Token stream is from Antler, so why is it not seeing my expressions lexer? So he's here. Oh, is it because the Kotlin dependent on Java or vice versa? Try this. I think I might have gotten it to work at home because I compiled it more than once, but I thought I had done enough runs through on it so that that wasn't an issue. But let's try this. Yeah, circular dependency there. So it goes the other way. I think I tried that and that didn't work. Okay, so now it's actually seeing the expression stuff. I think it's because I bootstrapped it by running it twice, which is not a good way to do this. I gotta figure out the right order to do those in. But now it's got those guys. Down here is where it starts falling apart. So let's fix up the parse tree walker. That's from Antler. And then this one's going to be expression listener. And I'm going to come in here and say class my expressions listener is expressions listener. Oh, I can do it either way. And let's take a look at what this guy does when I have Alt-Enter to implement members. Boom. So here's all the things here. Enter things and exit things are those methods that go around that things rule. Visit terminal is going to get called for each terminal node. Those are the tokens. Enter every rule is if you wanted to have something happen at the beginning of every single rule that gets fired. You could call that guy. Same with exit every rule. And visitor error node is if it inserted an error to say there's a problem, then you can deal with it. I'm not actually going to implement these right now. We'll come back to that. But that gives us a little thing that we can actually run. So instead of expression here, I said things. And let's try running this. So no such file, expr1.expressions. Didn't define a file for it yet. This is going to go at the root of the project. So new file, expr1.expressions. I'm just going to call him a text file. I should note, you notice how I'm getting coloring here in the Antler editor for the G4 files? That's because earlier I had imported the Antler plugin. So if you create a .g4 file, IntelliJ will put a little box up at the top here saying, I have some plugins that can handle that extension. Do you want to do it? And you can say, yep, import it. It comes in and it gives you the grammar editing capability. So definitely install that plugin. Okay, so this guy here, we're going to have 3 things that I have to type in. Let me just first of all type in one thing. Let's see what happens when we run it. So we have here line 1-4, mismatched input end of file, expecting ID. So it's saying on line 1, column 4, that's right here, is expecting another ID. So if I came in here and said foo, fee, and then run it, syntax error, it's space. Now you asked about the spaces before. When we take a look at our grammar, this space doesn't matter. We're just saying how we're going to create our tokens together. But we still have to tell the Lexer what to do with spaces. So anytime we see something that's white space, do we want to consider it significant? Do we want to throw it away? Most of the time you're going to want to throw it away. So we're going to have white space here, and I'm going to say it's going to be either a space or a new line or carriage return in case you're on a Mac. On Windows, you need both of those as well. Or let's say a tab. Those are our main culprits there. I'm going to say skip it. So this tells the Lexer, anytime I see spaces, throw them away. Now I could be a little bit more efficient here by putting a plus sign on that, saying anytime I see a group of spaces, throw them away all at once. But the spaces will go away now, and now they're just used to separate tokens, because a space is considered a token. So I saw a thing, a space token, a thing, a space token. I'm throwing away the space tokens, and I'm leaving just the thing tokens. When I run this now, boom, build successful. And we'll see here, this is what our parse tree looks like. So we have a things node with 3 arguments in it, pla, foo, and fee. Told you it looked a little like this there. Make sense so far? Let's get a little more interesting. So we've now had our things at the top there. Let's actually deal with expressions. Now normally in most types of parser generators, writing an expression grammar is a real treat because of precedence. Let's see, you've done one before? Or it's a real treat. There's a whole structure of rules. Each rule acts as one level on the precedence chart. Well, fortunately in Antler 4, Tare came up with a way to have the grammar do the work for you. So we can define a rule that is left recursive. Normally that's deadly in a recursive descent parser, which Antler is. There's 2 main classes of parsers, recursive descent, which are top-down, and there's bottom-up ones, LALR parsers. Those are stack-driven usually. And with those, with a recursive descent parser, because everything's just a method calling other methods, left recursion should put you in an infinite loop. And there's ways to mechanically work your way out of that and put it into a non-left recursive grammar. He just did that under the covers. So this becomes a lot easier to deal with. Let's make a real simple grammar here that has our 4 mathematical operations in it. So I'm going to say expression is at the top here. And sometimes you'll see people just write EXPR for expression whenever you see it in a grammar because some people are impatient and don't want to type the whole thing. And what I'm going to do is say an expression can either be, and you do whatever the top precedence is first. These guys have the same precedence, so they go on the same line. Boom, just like that. Or plus, minus. So those are our two combining operations that we're doing there, with an operator in the middle there. Then we have terms. These are kind of the low-level guys, basically numbers and variables, things like that. Let's say it can be a variable name. Or it can be an int, which means we need to define an int rule. So I'm going to have a really simplistic int rule here that's just going to say any sequence of 0 to 9s. So at some point, you could in the grammar type something too long. That's when you'd want to have your code behind the scenes do some type checking to say, is that actually valid? So inside here, I'll say 0.9 plus. There's a nice simple int rule there. So here is my expression parser, very, very simple expression parser. I'm going to go over to this expressions file here, and let's say x plus 3 times 5 divided by y minus 4, something like that. Let's try running them. And somebody's not happy. No things anymore. That becomes expression. Yeah, he's going to be completely whacked. Okay, there we go. Let's try him again. Oh. Well, that actually wasn't a compiler error. That would actually be a runtime error. Yeah, in Kotlin, that to-do function actually throws an exception. So that would be at runtime. Oh, that is. This is a runtime at that point. So we can see that it actually did put out our output here. And we can see all these little expressions kind of grouped together. So x was an expression, 3 was an expression, 5 was an expression. Here's the 3 times 5. Here's the 3 times 5 divided by y. Here's the minus 4 at the very end of all this. And then we bring it all together. Make some sense? Very cool stuff here. So let's say that we want to actually have this evaluate that for us. Now, in order to do this, we're going to need some variables. Let's go ahead and add some variables into our grammar here. We've got this guy here as an ID. We're going to need to allow an assignment to it. So let's say expression list. An expression list is going to be how do I do this here? Assignment or expression. Actually, let's do it this way. Followed by at least one expression. Ooh, that's not going to work. That's going to be ambiguous. Antler has infinite look ahead, so that might actually work. I was worried that it's going to swallow this guy up inside the loop there, but I think that'll actually work because of the infinite look ahead. Let's find out. Assignment ID equals expression. Something like that. Let's see if we get lucky. I'm going to come over here. Let's say x equals 10, y equals 20. And let's try running it and see if it recognizes it. What I'm doing so far, since we're not actually processing anything yet, this is what's known as a recognizer. A recognizer is something that will parse and just tell you, is it valid or not? Okay, let's see what he's not happy with here. Oh, it's going to be the, yep, of course. This is the big drawback with using this expression listener, is that anytime you change rules, you may get, this thing may blow up. Usually your grammar gets to a fairly stable-ish state and you're just adding a couple rules and tweaking some rules. You're not completely rejiggering the whole thing. But you know, this is a potential problem. I should turn off this generate to do stuff.
You're just adding, you're just generated the missing methods, right?
That's true if I'm just adding, yeah, rather than just throw it all away. That'd be a little bit of a shortcut. See, where were you 2 seconds ago, you know?
You already deleted them by the time I already got that.
Okay, there we go.
Control D.
Okay, so that's interesting.
Oh, you asked for
Oh, I called expression. So it only, so at that point it only parsed the expression and didn't get the rest of the output. So one thing that we should take a look at is putting in an end of file flag in there. This end of file token is a special token that gets read at the very end. If you don't have it, we can get results happen like I just had happen there.
Okay, just like stop reading.
Yeah, it just stopped reading. Although since I don't have an end of file here, like if I put an end of file in here, saying well, I couldn't put it after expression. Yeah, it's not going to help me if I accidentally still call expression. But basically, I'm reading one expression and stopping. So on the x equals, it's saying, hey, that's not an expression. I'm done. So I need to change this to say expression list. Over in here. And now, we should get that whole thing. There we go. Ta-da! And then the end of file at the end there. So now we have a list of assignments and then expressions. Let's actually make it do something. And to start with, I'm not going to use the parser listener for this one. I'm going to do it with some actions inside the grammar. I should have just done that to start with and not had to deal with these guys. Whoops, I commented out the wrong thing. Get him out of there, and get him out of there. And then this can just all go poof. Just make sure that's still okay. Yep, looks good. So in my grammar, I can add in actions by using curly braces.
What you're not going to recommend us do.
This is what I'm not going to recommend you do because this can be a real pain to debug, especially like while you're developing it. I mean, the grammar compiler can give you all sorts of nasty, weird error messages, and trying to figure out where did I screw up is a real pain in the butt. So inside here, I'm going to do some action, and this can be Java code. I mean, it could basically be code in whatever language you're targeting. Antler can target any number of languages. You just need a different code generator for different languages. So this will be Java code, and this is another reason why I'm not recommending it. What I did in my example was I created a Kotlin class that did all the work, and then just put calls to the functions inside the grammar. So the grammar was as minimal as possible, but it just calls the functions. I'll show you what that looks like a little bit.
Because it just gets ugly in here, it's hard to sort of...
Well, because you have to write Java code in here.
And just layering Java code inside of the grammar gets kind of...
It depends. It's not too bad. You'll see in a minute it's really not too bad. The problem was that I wanted to write my real code in Kotlin. I didn't want to write Java code.
You can't do it.
There's no Kotlin target for Antler yet. I should check to see. Maybe somebody has by this point. I mean, Kotlin's still pretty young, so I don't know. And since this is all going behind the scenes, and most of the time they don't recommend you put actions in the grammar anyway, it's a moot point because Java and Kotlin are nice and mostly incompatible. So inside here, I want to do something with that expression. I'm going to create an @members section in here. And this guy is going to have a hash table. So we will say map. This is the other thing is you have to type all these imports and everything by hand. Not my favorite thing in the world. String. Integer. That's right, I'm in Java. Variables. New hash map. Something like that. And then inside here, I can say variables, put $id.text and $expression dot something. I'm going to have to put that there in a minute. So what this is going to do is I want to evaluate the expression, have it return something to me. Well, that means that the expression rule has to have a returns clause on it. And I say inside here what I want it to return. just going to say int value. So now I can say expression dot value is what's coming back. So I'm going to find that value, put it in my hash map when I assign. Now, if I had multiple IDs in here, you can differentiate between them by passing in a number to say which one you're talking about, but it's easier if you put a label on it. So if I said like name equals in front of that, I can then say over here $name dot text. Something like that. Make some sense? Try not to do that too much, because the more you put these in, the more it kind of pollutes the grammar. It's more to look at. And these names have to be unique in the file. They can't match any other rule names. So now down in this expression, I have to deal with this value. So for each of these guys, I'm going to give them, because there's two of them, I'm going to give them each a op1 and op2. And let me think about this for a second. I want to have this do something a little bit different depending on what the operator was. I can either put some logic in my action to say, if it's a star, do this, else do that, or I can split this rule up a little bit. I don't want to split this into two alternatives on different lines like that, because then I'm giving a different precedence for times and divide. Instead, I can split it at this point as kind of a sub-rule and do this. Boom, like that. So now I'm keeping the same precedence there, but it now gives me a place to put those different actions. So over here, my actions are going to be $value equals $op1 dot value times $op2 dot value. And I'll do the same kind of thing over here for him. Let's repeat that so I can just do the same kind of thing for my plus and minus. Like that. And then here, I'm going to say $value equals, I need to look up that variable. For right now, I'm going to assume it exists. I'm not going to put any error checking in there. We'll say variables.get $ID.text. Now, the $ID itself points to that token. The token has a bunch of information in it. The actual text, it has the starting position, the starting line, that type of thing, the end position, end line. Yes. Oh, no, this one, no. Thank you. That one you don't. Over here you do, but not this one here. The only time you need the dollar if it's an ANTLR specified thing, so if it's something that's in the returns list, if it were a parameter coming in, which you could do. If it, let's see, if it's a label that you put on a rule, then you need it, or a label that you put on a token. But this one, since it's a member variable, the function, you don't need it. And the $ stuff gets translated into the variables that ANTLR generates. So I'm going to take that and also do it for this guy. Value equals $int dot int. They actually have a nice little shortcut method that does the integer translation for you. Whoops. Where the heck is my insert key in here? There. No idea what I hit. So this will convert the text into an integer for you. Okay, and I think that's everything we need there. And this expression will then return a value. So now I want to have my expression list return a value. And I'm going to go here and say $value equals $last.value. Something like that. Okay, makes sense so far? Now, this will be the value returned when I call expression list instead of its parse tree node. So if I come into here, now I'm going to say value equals that. And I can just print the value, kind of like that. Run this. And we got a whole lot of nothing there. Oh, I actually have to say dot value. Oh, I'm sorry, it does return the parse tree, but the parse tree has that as a field. I forgot about that. There we go. And so I can say tree.value. In Antler 3, it used to do that. That doesn't look right, does it? Or is it? Maybe it is right. So 13 times 5.
15 divided by 20.
Yeah. And what's it tell me? 10? No. So it's 15 plus, 15 divided by 16. Plus, yes, it'll be 0. That's right. It's just 10.
But why is it?
You do this first,
Right.
then you divide by y.
Right, which is
So that's 0.
No, you do one minus 4 first little precedence.
Well, he'll be the last thing done. Or he should be the last thing done, right?
Yeah.
So it should be 15 divided by 20, which should be 0.
But that's not what we
That doesn't look right.
We can look at the parse tree.
Let's look at the parse tree and see what it says here. To do my assignment, so x plus, let me actually put this in a different editor so we can actually read this.
So is there a way to improve that out for indentation
The listy.
I don't know. There might be. Let me take a look. Let's see. Is there a... I wonder if that filters.
You know, multi-line indented tree.
It doesn't look like. I wonder if there's a pretty printer. Antler 4.
It should be 6, but it's 2.
That's ancient history there. Pretty printing the parse tree. Tree utils print tree. Is that something that's inside here? That's probably not. Oh, it's somebody's special code that they did. Now we'll deal with that another time. Let's take a look here and see what's happened with this guy. So we have our assignments, X and Y. We're going to say this is X plus 3 times 5 divided by Y. It's actually, it's doing that minus 4 early. That's interesting. Because this, it's giving me minus 4, Y minus 4 precedence. That definitely explains it. I think the problem is that, if I remember correctly, Antler won't let you split things up like this if you wanted to do automatic precedence. I think it only has that certain format. That's sounding vaguely familiar. Antler 4 automatic precedence. I bet if we restructured this, it'll work. Let's try it. If I switch this back, this will obviously give us the wrong answer. We'll fix that up in a minute. Let's see if that looks right for the parse tree. I didn't take that into account. Let's just kill those.
So you just need to multiply and add weekend numbers.
Okay, let's see if that. So we have, here's our first assignment. Here's our second assignment. That looks better. Yeah, I think that's what the problem was. I remember this from a while back. There was a special rule that you had to format it a certain way in order to take the auto precedence into account. And I forgot about that when I started going through this example. So what we need to do at this point then is break down what was the operator and go from there, which is unfortunate because I like doing it the other way first, or I like doing it the other way better. So now over here I can say if up, let's do it this way, time, come on fingers, times dot equals up yes, thank you, dot text else, and then we'll have this do a dollar value equals dollar op1 dot value times dollar op2 dot value. This will be divide. And then I should be able to do the same thing for, this isn't quite as elegant as I would like it to be.
Is there like an integer dot?
Let's see if that actually comes back now. Semicolon expected. Boom, boom. Not doing Kotlin. That's better. 6. Ta-da! Okay, so that is a little thing. Boy, I'm glad I remembered that because it's a little subtle thing that it can do this automatic precedence for you if you have that format on the line of expression, operator, expression. It has to all be just one piece like that. A little unfortunate. But that also makes it nicer if you push this code out of the grammar. But right now it's like the grammar is doing everything for me.
So if you didn't have all of them on, or if you had all of them on the exact same line, they'd all be the same precedence.
Not necessarily the same line, but it's the same alternative. So if I went in here and had this guy say
Or
plus or minus, then they'd all have the same precedence.
Mm-hmm.
But if I put just after this or and then had the other alternative, it really counts as a separate alternative, even though they're on the same line.
Yeah.
Okay, so questions so far? So that worked out okay. Let's move this code out of the grammar. Still use the action calls, but move it out of the grammar so we clean things up a lot. So I'm going to make a copy of this grammar. That's the generated stuff. Let me close him before I start editing it. And let's say expressions 2.g4. And let's set this up now. What I want to do is create a helper class. I'm going to go into my sample here. call it calc. And this is going to have some fun little calculations for me. Let's have him track the hash map for me. I'll make it actually look like Kotlin code. Yay! And then I'm going to create an instance of him inside of here. Calc equals new calc. God, it pains me to write Java code now. It's like, that is just so redundant feeling. So now we have an instance of a calculator that we can work with here. And let's say here, calc.setVariable, name text expression value. Simple enough, right? Now let's do the multiplication and addition and all that stuff. I'm going to come in here and say dollar value equals calc dot op $op dot text $op1 dot value $op2 dot value, something like that. And then we'll put the same thing down here. This will be calc dot get variable. And that one, I guess I can just go ahead and leave that in line as is. So I've now reduced the code inside the grammar a lot, which makes it so I don't have to have that, it's a lot more readable grammar-wise. And I can now do more of my editing in Kotlin, where I'm happier. Be my happy place. So I'll say val op string op1. What's that? Thank you. It's a very fun op. Int op2 int, and then inside here I can say when op, and we'll say times, then op1 times op2. Minus plus divide. Throw argument exception, since you wanted argument exception instead of state exception. There we go. And is that all I needed? Oh, I needed to get variable and set variable. So we'll say fun get variable name string, come on, equals variables subname, and fun set variable name string value int variables subname. Wow. This keyboard is a little bit more compact than the one that I was using all day. That's my excuse right now. I'm standing with it. Yeah, no, what you'll believe is, man, he's a lousy typer. I type by the Columbus method. Find a key and land on it. Yeah. Okay, so one of these days I gotta learn to type. I'm really wondering though if I'm gonna stave off carpal tunnel because I'm so random the way I use the keyboard. Okay, so we have a get variable and a set variable. Was that all we needed in here? I think that was it. And which one?
Then, yes, I think we've got op and
okay.
set.
And so let's go back over to the example and tweak this. Instead of using expressions lecture, we'll set expressions to lecture in parser. Exciting. And let's try running him. And there we go. That seemed to work just fine. Got the same type of result. Questions so far?
This way, the way you want us to do the execution?
No.
Still no.
Still no. Yeah. If you do it this way, this is a really simple grammar, and part of the problem is the more that you do inside the grammar, the more you have to do manually, the easier it is to make typos. This is yet another language for you guys to learn, and getting the syntax wrong in here is real easy, and unfortunately Antler is not the most helpful in how it tells you things. One of the more common things is, hey, I didn't expect to end a file, and that's all it says. Which means somewhere along the line you've got a mismatched curly or a paren or a semicolon. Something is missing. And a lot of times that's all it'll tell you is like, I hit the end of file and I wasn't expecting it. It's like, thanks, you're helping me a lot, Antler. But yeah, what we'll do is we're going to move to the parser generator, or the parse tree listener, to actually do the real work for this. And then it's a little bit more work inside. One of the things that's nice about this approach is you can treat these as function calls. And so you can pass data down, you can pass data up, however you want to do it. So in this example, it makes sense to get the results percolating up, the return values. But for other things, it might make sense to push values down, in which case I would say, maybe I have an expression that takes a int foo, and then in each one of these guys, I could pass in arguments, that type of thing. So you can pass data around, and I like that because if you have something simple, you can do pretty much everything in the grammar. The problem, though, is that the grammar gets cluttered. It gets hard to see what's going on there, and it's real easy for there to be typos. Rule expression is left recursive but doesn't conform to a pattern Antler can handle. There's one of the things there. What did I just do?
Maybe you need to rebuild it.
Probably, yeah. Oh.
You control Z your way out.
Yeah. Back to the same thing.
It looks like the same thing, doesn't it?
It looks like the same thing to me.
Ah, that's weird. Okay, so questions so far? Making some sense? No? Good.
For the assignment, you have the name equals ID equals expression.
Just lost power.
I was wondering if that was thunder.
On a new line.
Okay, one more
Is
time.
that so you have the ID equals expression for the assignment rule on a new line. Is that a stylistic? Is it a stylistic choice, or is there?
So
a reason for having
this guy here?
No, it's up to the assignment.
Oh, this guy here.
Yeah. Is the reason why it's on a new line just stylistic, or is that?
Oh, for the colon there, you mean?
Yeah.
That's just a general style people have been doing. Some people like the colon on the same line. I always like the colon over here because then you can line it up with the vertical bars, and you really just see the alternatives next to each other.
I was just curious.
It's just a stylistic thing. This is the style I've been used to, and it was a style I learned a long time ago, and I can't remember what tool it was. I don't know if it was Lex or Yak. Lex or Yak does something a little different, but there's it might have been with PCCTS that I picked up this style. And unfortunately, Xtext always wants to put the colon immediately after the rule name, and then I have to constantly shift it down, and it drives me insane. But yeah, it's just a style thing, and I've just kind of grown to like this, where as much as I can, I like to try to keep an entire alternative on one line, unless it starts getting a little too big. And you'll notice that I broke it up more once I had those sub-alternatives and things like that. So yeah, it's just kind of a style, you feel your way through it type thing. Okay, other questions? So now let's take a look at using the parse tree to do the same kind of thing. So,
Take a quick break.
yeah, let's take 10 minutes. So we'll say 6:10, we'll start back up again. And we're back. So what we're going to do now is convert this to use the parse tree listener. And this is the approach that I want you guys to do for the assignment. Or I'll say this is the approach that I very strongly recommend you do for the assignment. If you really want to do the other one, feel free. Just make sure you get it done. I'm pretty sure I'm going to give you guys 2 weeks on this assignment, mainly because this is a new language to everybody, and it's a very different way of looking at the world. What we've all done so far in programming is imperative programming. And what we started to do with looking at DSLs is do declarative programming. So we're really kind of declaring what we want things to be, kind of like in our expressions language here. We're really giving a more declarative function, a form of what we want to have happen. Antler is a declarative language as well. If you ever use something like awk, has anyone used awk before? It's an old Unix tool where you would set up regular expressions and then action blocks to say what to do when that expression matches. And it was fairly useful. It's kind of similar to what this is, but it's all dynamic as opposed to compiled and things like that. And regular expression based as opposed to grammar based like this. Okay, so what we're going to do is get rid of all of this extra cruft. I don't need that members block anymore. I'm not going to need these imports. I'm going to get rid of, where's my end key? Come over here. Oops. There we go. So that cleaned things up quite a bit there. Whoops, I missed this guy. So one of the things I like about this is that now we're really just looking at the grammar. There's certain things you're going to want to put labels on just to make them easier to access from inside that parser listener. You can put labels on the on the rule calls that you're making here. So I could say op1, something like that. In general, you don't need to. It just kind of depends. It depends on how you're using the parse tree listener. In each of these, what we're going to be doing is the expression, the enter expression or exit expression is going to be called for each one of these sub-expressions, then for the parent expression. So we really are not going to say, hey, parent expression, give me op1, give me op2. So we really don't need to label those guys.
We get enter parent, enter 1, exit 1, enter 2, exit 2, exit parent.
Yeah, but they're all the same enter and exits. So it'll be enter expression. So when we come into here, enter expression, come into here, enter expression, then exit expression, come back up, enter expression, exit expression, come back up, exit expression. If that makes some sense. Okay. Oops, I got one more up here I'm going to get rid of. Boop, 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 boop. Just like that. And this guy. Get rid of last. There, that's so much cleaner now. So now what we're going to do is go back and set this guy up to be expressions 3, and I'm going to use the build tree parser. I'm not going to print that guy out because he's not going to make any sense. And I can either do the parse while I'm walking, which would be adding the walker before I do parsed expression list, or afterwards. I'm going to wait until I do afterwards here. So let's take a look at this. Yes?
So doing it during buys you what? Maybe not having the whole thing in memory?
You actually don't have to walk through it a second time. So it's like as it's actually being parsed, it's walking, so there's a slight performance gain there versus doing 2 passes. Doing this as a second pass down here ends up making sure that everything's already been resolved first, so you have all the references, and then you can work off there. Now, we don't have to use a parser listener for this if your grammar wasn't as recursive as this one is. Let's say that we were doing one for that state machine, where we have the state machine has states, has transitions. You know exactly what everything is at each level. Then what I could do is I could create functions that take, start at the top and say, hey, for the state machine, walk through all the states. For each state, walk through all the transitions. And it could just be one big function, as opposed to using this visitor pattern. And for a grammar like that, It'd be much simpler. With a visitor like this, you're going to have some intermediate variables to keep track of things, like a stack, like a variable to keep track of what your current direction is that you're working on, that type of stuff. So let's create this listener here. Class my, what did I call this thing? Expressions listener. So it's actually going to be expressions 3 listener. Yeah, I'm going to need to build it before I actually go any farther here. And it goes kaboom, of course. Implement those. Now, when you're implementing these, you don't have to implement all of them. You only have to implement the ones that you think you're going to care about. So usually, these ones that are like, look at everything, I usually just throw those down at the bottom. I got to take a look at the error node thing and see if that's actually going to be helpful.
What's the terminal one again?
The terminals are ones that aren't rule calls. They're actually references to Lexer rules, so the tokens. So that'll be called for each one of your tokens. So now what we have is enter expression list, exit, enter assignment, enter expression, exit expression. Good. So that all looks pretty good. So let's think of what we have to do here. For the expression list, we want to make sure that we've already processed everything so we have something to return, right? So we really care about what happens after the expression list has been processed. So we're going to handle him with exit expression list. I'm going to move this guy out of the way. For assignments, we want to make sure that we've already processed what's the variable, what's the other guy, before we actually do the value. Now, depending on how we implement these, the actual expression operations, I'm going to implement it using a stack. We may want to process and push and then pop at the top level. Or if we didn't have something as recursive as this, do that same type of structure I was talking about with the state machine, where you can just have one big function that says process this level, process this level, process this level, I'm done. Most of these, I think in this particular grammar, everything's going to be an exit that I look at. For your assignment, I'm trying to remember if there's any that it is. Yeah, for your assignment, what you're probably going to want to do is for the layouts, have the enters actually create the panel with the layout and push it on the stack, and then the exit, pop that off. And then anytime you have something being added, whether it's another layout, whether it's a button, whether it's a label, whatever, those are going to say, let me peek at whatever's currently on the stack and add to it. Does that make sense? So you're probably going to want to bookmark the layouts with the enter and exits, and then the actual components themselves, you could either use the start or the finish. Doesn't really matter. Make some sense?
And you would create that stack or that map inside of the listener.
Mm-hmm. Yep. And he'll keep track of it. So we're going to create here. We're going to. There's different types of processors out there, like an x86 or the Mac chips, or the Pascal P machine. The Pascal P machine was stack-based. The Java virtual machine is stack-based. Anytime you evaluate things, you're evaluating it, pushing the results on the stack. When you want to evaluate the next operation, you're popping stuff off the stack and evaluating. So when we think about how we evaluate expressions, when we're inside here, I'm going to go down, evaluate this expression, blah, 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 percolate down until I get to this level with the IDs and the ints. All I'm going to do for processing that ID is push that stucker on the stack. When I have something plus or minus something else, I'm going to push the first thing, going to push the second thing. Then to evaluate this guy, I'm going to pop those two and then apply the plus or minus to it. Make sense? Take that result, push it on the stack. And so this gives me a nice set of operations to perform. For your assignment, you're going to need to do that a little bit. For the evaluator part of it, you're going to need to use a stack for that. Keep in mind it's a separate stack from your actual components. I suppose you could use the same stack. I wouldn't recommend it.
Seems like a lot to keep track of.
Yeah. Oh, and by the way, that disaster of a bad idea that any operation I've removed. So I know a lot of people were having questions about that, saying, "What the hell is this thing?" It was one of those things when I was writing up the assignment. I'm like, I really want to have a nested scope, and I was trying to just dig for something, and that came up at 3 a.m, and I shouldn't have gone with it. So my apologies for the pain that caused. It's not in this next assignment. I'm going to try to, for future versions of these assignments, come up with something else where I can demonstrate a nested scope. Okay, so we're going to be dealing with the exit expressions on most of these. Now, exit expression list is just going to say, once everything's been processed, grab what's on the stack and return it. Boom, I'm done. Let's create a little stack with values here. So I'm going to say val stack equals stack int. And don't give me crap about using stack. I know it's from Java 1.0, and I know that it's synchronized and not as fast as something else, but it's already got the push and pop baked in. I'm going to use it. And what is this, 2018? Machines are fast enough. Who cares if it's synchronized?
There are other Java collections with push and pop built in.
I don't think so. I'd have to look. But I think that's probably from early Java as well, though. I don't think there was a. I'd have to see.
It doesn't matter.
But I mean, you can obviously do it with a list or something like that. But I'm just saying, screw it. I'm going to use a stack. So when we're doing our assignment, he's going to need to pop off the value and then assign. So let's go ahead and do him first. I'm going to take him and move him down out of the way because he's kind of simple. And what he's going to say is val value equals stack dot pop. And where'd my variables go? Oh, they're up here. Let's see. Do I want to keep using this calc guy? You know, I might as well. Or I can just move these inside. I'm just going to move these down. No, you know, just for consistency, I'm going to keep it up there and just create a calc instance in here. Okay, so inside here I'm going to pop that off the stack, and then I'm going to say calc.setVariable. And I need to get the name, which is going to come out of this context here, the assignment context. Now you can actually, if you want to, get rid of these question marks. Antler is always going to be passing in non-null values for these guys. So you can remove those if you want to, and that makes it so you don't have to constantly do bang bang on all those. The reason for that is Kotlin has to assume that it might be nullable because the actual interface doesn't explicitly say.
Oh, because it's a Java interface.
It's a Java interface.
So this still counts as implementing it because Java doesn't say.
Yep.
Okay.
And we're just getting a little more explicit, saying, "Hey, I know that's actually non-null, so it's fine." So we're going to call calc set variable. I'm going to have to go to that context. Let's take a look at the grammar.
Sorry, if it was null, we just get a null pointer exception like we would in Java.
Exactly. So if we look at the assignment, I grabbed a little label on here called name. So in that context, it creates a name field for me. And so I can say context.name, which gives me the token for that name. That's a string token. And then I can get the text off of it like that. However, depending on how you're implementing your language, if I had a string rule, which you guys are going to have, and let's see, what the heck does this look like? And then dot star question mark, like that. Yeah, I think that's a string. So this is a non-greedy anything. So dot means any character, star means 0 or more, and the question mark makes it non-greedy, which says take into account that next character there. So what this is going to do for us is create a token for the string. But that token is going to include the quotes. So be careful on that. There's, I think, 3 spots that this is going to affect you. When you have string literals, when you have text on buttons, and when you have text on labels. Make sure you strip those quotes off. And it's just a matter of doing a substring from 1 to the length -1. And then, boom, that takes care of it. But this one had me going for a little while because I was doing my validation saying, I don't, make it invalid if it's, or make it valid if it's not equal to a certain string, and it was never coming back true. And the problem is that the string that I was getting from the grammar was quoted. And I suddenly realized, I'm like, oh, damn it. And then I did strip quotes, boom, it worked just perfectly. So, back over to here. This guy we don't need to trim. I just wanted to talk about that while I was thinking about it.
That's just the very beginning.
Then I'll pass the value in. Boom, there we go. So that's what our exit assignment looks like. He's nice and simple. Enter expression. Again, I'm going to work at the end of expression, so I'm going to get him out of there. Exit expression is going to be the big guy. He's going to have to handle all the interesting things. This is going to be similar for you guys. So let's see what we have in here. We have our operators are plus and minus, and I have him held on to his op. I'm going to have 2 expressions. Now keep in mind, since this is a stack-based machine, I'm pushing them on in the order of the left-hand side followed by the right-hand side. When I pop them off, what comes off first? The right-hand side. Be careful on that. There's some operators, and I think for this assignment it's not going to really make a difference, but there are some operators that may be associative in a certain direction, and that can end up frying your logic if you're not careful. So let's come back over here. And this guy's going to have to say, let's take a look at that context. Well, first of all, let's get our operands. So I'm going to say val right-hand side equals stack.pop. And left-hand side is stack.pop. And then when op, actually, I can just call calc. Yeah, call calc op on there, right? Yeah. Return calc.op, passing in context.op.text, and then left-hand side, right-hand side.
That doesn't handle
Oh, not return. I need to push it.
the int and how do you differentiate if you actually have a binary expression versus a terminal?
If I actually have a binary expression versus... Oh, you're right. Yeah, so in this case, if we come back here, I forgot about these 2 guys down here. Those we have to deal with, ID and int. So one thing is we're not going to have op. Op will be null, which means it has to be one of these 2 guys, but then we need to know which one of those guys it is. So we can look for the ID or look for the int value and see which is non-null, and then that'll tell us. I'm going to go ahead and put in a couple labels on him just to make it a little bit more clear what's going on. Something like that. Let's run a build here. It'll go kaboom, that's fine. We'll come back over here. And so now let's say if variable, context dot variable not equal to null, else if context dot int literal is not equal to null, else this guy. Yeah, glad you called me out on that one. So now inside here, if it's the variable, then we want to actually look that variable up. So I will say calc dot get variable, passing in context dot variable dot text. So I want to get the text of the token, and then we will just push that on the stack. And we'll do the same thing down here. For the int literal, so I'm not getting him. We're just going to say context dot int literal dot int, Oh, shoot, that's not going to work. Let me come back over here. Yeah, I'm going to have to convert it myself because I'm not using an action. I can't use their .int thing.
And
So-
you got text.2int, right?
I looked at that, it said toucan index. I'm like,
That's what I read too.
it's like I totally read that. I'm like, that's interesting. So we'll say text.toInt. There we go. And that looks good there. So this takes care of our expression there. Push it on the stack. We'll pop things off as needed to combine them. And then finally up here for my exit expression, this guy's going to say after everything's done, just whatever's left on the stack, that's the end. So I'm going to say stack.pop val result equals, and then I can just say println result. Or alternatively, what I could do is store it in a field here and then have the main fetch it if I needed to get it that way. So this walker should now evaluate my tree and give us our result. There we go, 6. Yay, I like it when things work. And it's fairly quick too. It would take 3 minutes on the laptops at APL though. It's just slowing us down, grinding us to a halt. Okay, that makes some sense? Now this one is fairly simple, right? There wasn't a whole lot going on here. As you start getting a little more complex, a lot more stuff happens inside here. You're going to have to keep track of a lot of different pieces. So let me see, was there anything in particular I want to warn you about on the assignment? Let me switch over to here and take a look. I'm going to pause my video.
In,
Pretty much. Yep.
But in an external DSL.
right.
Yes, in an external DSL. So I will show you what that external DSL looks like in 1 second here. Good, the recording is going. Okay, so a couple little things to watch out for here. Notes, not text, how about that? Container.add in AWT can take one, 2, or 3 arguments. By default, normally it takes a component, and that's going to be the one that doesn't take the direction. So you can use him for the non-directional ones, and then component, comma, object, which is where you pass in border layout, dot north, south, east, west, and so on as the result there. If, depending on how you implement it, you want to always call this guy, you can pass in a null for that object. That's perfectly fine. So just depending on which way you're implementing things, you can either have 2 separate calls, or you can have just the one call. It really depends on where you end up putting that add, where that happens in your parse tree. Okay, makes sense? Let's see. Let me quickly kill him and show you what the grammar looks, or what the file looks like. So here's an example GUI. Let me start with the simpler GUI. Here's a really dirt simple GUI. It's always going to start with frame, and then you're going to have the directions immediately followed by some other component, which could be another layout, right? In this case, this is just going to have the 4 directions, boom, spin them up on the screen. Life is peachy. This one's a little bit more complex.
You're throwing away white space.
Yes, white space is thrown away. So, if you wanted to, you can put extra spaces in at any point, and that all just gets thrown away. Okay, so this one's a little bit more complex. It has, in the south, just a grid layout with OK and cancel. So they'll just take up the entire spot on the bottom there. Then this is the bigger one. And I changed the validation on this to get rid of the any. So there's no more any. There's no more get all fields operation, because that's the only place that we needed that as well. And this is kind of what things look like. So the validation takes expressions that look kind of like this. Note that I implemented not equals as less than, greater than. That's Pascal style. I think, is that how it's done in Squeal as well? I can't remember.
No, it's that way in different places.
Okay.
I'm pretty sure that's
Yeah, I mean, this was a really common way of saying not equal for a long time. And then when C came along, bang, equals came up. So this is kind of what the syntax is going to look like. Not name.empty and name is not equal to blah. So this first field should take anything other than a blank or plow. The second field, a little bit more interesting, but not much. He's not empty, and he's either foo or bar. So those are the only two values. Now that's redundant, right? Because I could have just said name 2 equals foo or name 2 equals bar, because that's not empty. But I just wanted to have them both in there because I wasn't thinking. Now the text age down here, not empty, and age is int. So the syntax is cleaned up quite a bit. And I actually had a pretty reasonable syntax for the anyone. I said any key value in all fields where, and then that other expression that was under there. But it was still just, the concept of the thing just really rubbed me the wrong way. It was just kind of gross to work with. So, screw it. Okay. For a grid, I say grid, 1 rows or 1 columns, 2 rows, 2 columns, whatever. You can't say both rows and columns. So it's going to be a number followed by rows or columns. The flow layout has a single direction there. It's going to be right, left, or center. You're going to need to convert those into flow layout.right, flow layout.center, and so on. Border layout doesn't have anything special there. You notice this guy says grid 1 cols instead of grid 1 rows. And if you want, you can experiment with different numbers of rows and columns, see how that looks there. And is there anything else in here that's interesting? On the text fields, the ID next to it is the variable name that's going to be storing in the top level. We don't have anything that has any nested scope here, so everything is just looking at the top level. But still keep the scope getting passed down. Yes?
Do you have to have the validation?
No, validation's optional. Yes, validation should be optional. I should have had an example in there of that.
So in the last one, go back to the last example. Sorry.
Oh, this one here? Yep.
No, the one you're thinking.
Okay.
So that one you just have at the top, line 3, it's just blank. So you have to tell it.
Oh shoot, that's actually that should not work.
Oh, okay. That's what I thought you were trying to say is no validation.
Yeah, no validation would be nothing.
Yeah.
Okay.
Yeah. Did I just type that recently, or?
That was there when you first pulled it up.
Yeah, that was bad. That was a bad example. I don't know what was wrong on there. That should definitely fail. Let's see. What else am I going to say? Now, in your code that you currently have a bunch of builders. Those are all going to go poof. You're going to take the actual construction of the GUI stuff and put it in that listener class. So some of it, you're going to save some of that code, but a lot of the stuff that was in there for the builders is just going to go away.
It would be more like a first assignment than the second assignment.
Yeah, kind of.
A mix.
Kind of a mix, yeah. Except this one has the evaluators. Now the big change in the evaluators is that you are no longer going to have generics on them. When I started implementing this, I had the generics on there, and implementing was just a nightmare trying to get the generics to all match up because I had some type checking going on. I realized we don't really need those generics because nobody is writing this stuff in their code, which is the whole point of having the generics there to start with. So I removed the generics. It made things a lot easier, but I added in something to keep track of. Let's see if I just comment this. This is actually what you're going to get. Where did I put that? Here we go. I added in this type enumeration, comparable string, int, and boolean. Hold off on comparable for a minute, I'll explain that in a second. But this is going to tell you what type this evaluator represents. When you're processing, I want you to check to see that the types are consistent. So if something is going to be used as a validator, you want to make sure that the type coming in is a boolean. If something is used on one side of an and or an or, it has to be a boolean. If something is used on one side of a less than, This is where comparable comes in. What I did when I was implementing this, and what I recommend you do, is the first operand you check, let's say it's the left-hand side, you're going to pass type comparable when you're fetching it. I created a little pop function that popped it off of the stack, popped the evaluator off, and then looked to see what's the actual type there, and passed in what I was expecting. So the left-hand side, I pass in this comparable type, and then when I pop off the stack, I say, is it a string or an int? If it is, it's comparable, I'm happy. Then for the right-hand side, pass in the type of the left-hand side, because they have to be the same.
You can choose the right-hand side first.
Did I do the right-hand side first?
If you're popping on the stack.
Well, you can pop them both off the stack, but yeah, either way. I mean, you can pop them both off and then do the checking, or if you do it as part of the pop function, then the right-hand side comes first. Yeah. So the right-hand side, you'd say passing comparable, which is just your little clue inside that pop method to say, is it string or is it int? If so, it's good. Then you're going to get that operand back, and you're going to want to pop off the left-hand side. At that point, you're going to pass in the type from the right-hand side, because they have to be the same. So string less than string, or int less than int. Does that make sense? So that'll be the type of checking you're doing there. For the place where you're actually doing the whatchamacallit, and I mentioned it for the validation, make sure that it's a evaluator boolean. Things like that. Make sense? I was originally starting to try to implement in the grammar, setting up the rules so that I had certain expressions were boolean expressions, certain expressions were ints, and so on. And I wanted to keep the grammar simpler. And so what I did is I kept the grammar to use that same type of expression parsing that I showed you earlier, where the precedence is spelled out there, and then did the type checking inside the parser listener. It really simplifies things. Okay, so these guys no longer have types. There is actually, I think, one here where I have a type. And if you want, you can use your own ones instead of the ones that I'm providing here. I just wanted to show you kind of what I was doing for the last assignment and how I converted it for this assignment. This binary evaluator, what I did is set it up so that I have the operator coming in, left-hand side, right-hand side. The operator is only coming in so I can print it out. And then I'm passing in this lambda to say what to evaluate for that binary. So when I created this binary evaluator, I was passing in a x plus y, x times y, x is greater than, x is less than, whatever. And then this test is just calling it there. You'll notice that I've added in here to the evaluate an indent coming in, as well as the scope. This is so that as evaluations are happening, I can print out information about what actually just got evaluated. So I'm going to pass that down by padding it a little bit to each of my nested guys. And then at the end of the function, I'm going to dump out the indent, the operator, and the value. And this method is just a common method up here that just kind of concatenates them together. I'll show you what that looks like in a minute. Note that that dump that happens during the evaluation is going to look backwards, because we're going to drill down all the way down into the tree, the bottom, the leaves of the tree, evaluate those first. Those are going to be the first things printed. And then it percolates up, and we gradually show what the results are on the way back up. I also have an explicit dump method which dumps the tree in the proper order. So it's basically a pre-order traversal as opposed to a post-order, which is this other one here. Yes, I should have just said that. It's like we're going down the tree. It's really doing a post-order traversal. And anything else that's interesting in these guys? Let me see if this will actually run. I think that's the right one. There we go. So here's the GUI. This is the little sample GUI that's presented here. And this is what I meant by it got collapsed up at the top because I put it in an extra border layout. It's in the north part of a border layout. This is now the center of the nested border layout. You'll see down here that the evaluators are getting run. I set this up so that anytime I add a text field, I keep track of that text field and its validation logic in a separate object. And I just have a list of those. Then, just before I call set visible to true, I run all those validators. And then that does the initial pass-through. That way I'm getting red fields to start with. So we're seeing here the evaluation of those validators to start with. So here's the first text field. There we go. And we'll see that here's his logic in dumping out that tree there. So I have an and, inside there is a not and a not equal. Inside the not is an empty. Inside there is the variable. Over here, not equal, name and pla. And then results, and I printed out reverse just as a reminder there. Here's that deeply nested looking up name. Actually, I think it's this guy up here. And then, is it empty? It's true. Not switches him to false. Combining that up with my and up here is the false. Boom. Make sense? So this I thought would help debugging a little bit, because these things can be a little bit of fun to debug. Similar for this guy here. I have, this is just actually checking for equality. I shouldn't have put those colons there. I don't want to put the colons. That was just silly. Here's the spitting out of that, and so on. So now if I actually go into the GUI and start type in my A, it's not equal to pla, so it's okay. If I came in here and started typing pla, as soon as I type pla, boom, it goes bad. It no longer has the requirement these two fields be different. The second field, though, has to be foo or var. Third field, valid integer, not valid integer. Make sense? Okay. So, the assignment description. Make sure I go to the right class here. It's going to be assignment 4. And I do have it listed as 2 weeks. I'm going to stick with 2 weeks on it. There's a zip of stuff to get. It has, first of all, the assignment 4 Kotlin code that has those evaluators that I just showed you. There's a build.gradle that you can use at the top level or copy over bits if you want to. I'd recommend creating a new project and just look at the build.gradle and see what the differences are. That'll set up for Antler. There's the GUI layout, GUI 1 layout, GUI 2 layout, GUI 3 layout. It sounds like the GUI 2 layout has some issues, so hopefully that's actually, it's intentionally an example to see if you fail. Yes, exactly. Yeah, that's the ticket. The evil any operation is gone. So what you need to do here, create an Antler grammar for that external DSL, name it layout. That way you'll get layout parser, layout lexer, and layout listener. The GUI 1 example is really the one you want to look at to see what the language looks like. If you have any questions about what's optional or not, let me know. If I had a little more time this afternoon, I would have written out a spec for it, but I think you get the idea what's going on. If you have any questions, let me know. First of all, test it as a recognizer. Just to make sure you got the grammar okay and you got it hooked up, it should complete without errors. Okay. Then do the parser listener. If you really want to do it in the grammar, you can do it in the grammar. If you do it in the grammar, I think the type checking is going to be harder. So be careful on that. Because with the grammar, you're typically just passing pieces up. As opposed, you could wrap them and then check them, but there's going to be a lot more work inside the grammar. I'd really recommend doing this through the parser, the parser listener. You'll need a mix of some enter and exits. Most of them will be exits. You're going to walk the AST after it's been created. That makes sure that you have availability for things like the direction. You know, what I did when I implemented this is I had a rule called direction, which inside of it had a dir field, which is north, south, east, west, center, followed by the component. So when that thing is actually processed, I'll have that direction and then the component set up. So in that case, I used an enter rule that said, once I got in there, look at that direction, save it in a variable, and then when that component gets added, if that direction variable is there, go ahead and use it. As far as the stack is concerned for the containers, I recommend you explicitly have a stack versus using parent pointers. I know for an earlier one, a couple people used parent pointers. You basically just said, here's my frame, or here's my J panel. I can pop the stack by just saying current container equals current container.parent. And that mostly works until you get up to the level of the frame. JFrame has either 2 or 3 extra panels inside of it that are kind of helpers. And so you'd end up having to say .parent at the last point. It's just easier just to keep track of the containers, the JFrame, and then the panels on there. So parser listener functions are replacing the builder classes. You'll need to come up with a way to do the initial validation. So I recommend having some kind of object that holds on to your field and the validator for the field. And then that's the thing that's going to do the validation. It should have the logic that has the watcher in there for doing the validation, but then also be callable from outside, so you can just say validate everything up front.
Rather than, like you did the initial one in whatever, homework 2 or something, by just calling it once during construction.
Right.
You don't want to
If
see
you
that.
call it there, the problem is going to be that you're still in the middle of parsing. And when I first was writing my thing, I got a concurrent modification exception at that point, because it was actually trying to walk through at that point, and it's just the wrong time.
So you basically want to call it before the exit frame.
We want to call it in exit frame.
In the, okay.
So do it like just before you say is visible equals true, and then you're basically validating it, making it visible. You could actually put it after the visible is visible. It's fine too. Either one of those, okay. I mentioned the parent pointers thing there. Take advantage of those dump functions that I talked about. So if you want to see what things currently look like in your evaluators, call evaluator.dump with an empty string. That empty string is the initial indentation. And then each level it adds another 2 spaces on there. I want you to create 3 sample UIs for this. Here are the precedents of the operators that I want you to use for this assignment. The first one is parentheses, which I don't think we did in the other assignment, because we're internal DSL, so it really didn't matter. But for here, I want to be able to say explicitly this section has certain precedents. Then expression.empty, toInt, and isInt, that's the next level. Not is after that. Then the relational operators, then the equality operators, then and, then or, variable, literal.
And the reason expression.empty, etc. are up there is because that's essentially the method call one.
It's basically a method call.
Implementing 3 methods, 3 functions.
Right. And when you're doing a language, there's a choice you have to make between, do I hardwire these things in the language versus do I call them a built-in function versus do I call them a library function? And you can hardwire these guys as, wake up, Scott. Wow, my mind just completely went blank there. You can hardwire them as keywords in the language. That's what I'm looking for. I was looking for the word keyword, and for some reason it was eluding me. You can make them keywords in the language. The problem then is that nothing else can use that same name, so I couldn't have a field called empty. You can make them, in the way I implemented it, is I used it as an ID for these guys, so it's basically a library call at that point. With library calls, you can define a set of, here are my current built-ins, these ones that come with the language automatically, or you can allow people to plug in other libraries and reference those libraries. For this assignment, treat these just as built-ins. So you can just directly have code that says, if the value is quote empty quote. That's perfectly legit for this. So you're really treating it as a built-in function at that point. Okay. So this is just a little kind of walkthrough of an example, pretty much the example I just ran through, showing you how it looks. Just one way to test GUI 1. Just, and if this is what you see when you run, then it looks like you're doing the validation like I expect. That doesn't say it's definitely doing what I expect, because other GUIs you might be doing things differently. After your testing, question time, yay! Your favorite part of the assignment. So advantages to using external DSL for this type of application. So for defining a user interface, what would be the advantages for defining a user interface externally as opposed to internally? That's what I want you to think about there. What type of disadvantages does that give you? Do you find the external parser easier or more difficult than the internal DSL parser that we did for homework 3, and why? Explain the advantages and disadvantages you see to the different approach. So if you see one has some pluses and minuses, the other one have different pluses and minuses, call those out. Do you find the external DSL layout definition? So these two different ones here, this is actually writing the code that handles the loading of the GUI. This is actually the code that defines the GUI. So using that internal DSL there, or the or the external DSL that we're doing in this assignment.
It's now not code exactly anymore.
I still consider it code. It's just a different language. So it's
Code in our DSL. Over here.
Yes. Yeah. I mean, it's, we're kind of blurring the line between code and data.
Right.
A lot of times people consider the difference to be, is it delivered with the app? That's one way people look at code versus data. Sometimes people are like, oh, data is always something separate, but not always. I mean, it could be delivered with the app as well. Some people say code is stuff that's compiled. Well, what's JavaScript? I mean, I still think JavaScript is code. And, it's gross, yes. Very, very gross. Absolutely disgusting little language. Yeah, I mean, there's different ways of looking at what that is. And think about, how do you deliver it to somebody? If you had a GUI defined in this external DSL, what are different ways you could deliver it to the user? As part of the application bundle or something else? And what types of advantages or disadvantages does that give? So you can do some really interesting things with these. Okay, make sense? Yes.
What how grading wise, how are you weighting the questions versus second ones? Like the last two assignments, or the first two you said were worth 50, right? So like what was the breakdown for number
generally the questions I'm only given in a couple points usually, unless somebody really blows it off. I mean, if somebody just said yes, no to each one of these, I'm going to knock you down a few more points than if you had made a reasonable attempt on it. So I'm really looking for you to kind of think through what's going on in these different types of situations. And I don't think I've had any problems with it yet. I'm going to try to get the grading caught up tomorrow, so that we'll have those last two assignments done. And then this assignment, yay! I'm not giving them too much, but it's the type of thing, it's like if you kind of blow it off, it's really going to limit your grade to probably an A- at most for that assignment. I think what I'm going to do next term is have all the assignments be 100 points, but apply weights to them as 50% instead of this 50-point nonsense. It's like, it ends up being the same in the long run. It's just when you look at your grade, it looks like a percentage. It was really bad in the other class where I now have the first assignment's 40 points, the second 60. And so it's when you have 40 points and you get a 36, well, what is that? It's not immediately obvious.
I don't know, you can't do that math. I feel like you shouldn't be taking a master's degree. Right? You just add them all up, you do the division.
Especially when we're grading a whole bunch of them, trying to decide, well, how many points do I take off for something is a little bit trickier.
Okay.
Although it's still, I'm squishy on the grading, so it's more. I think this is going to be a B, and then I calculate it from there.
Okay.
But yeah, it's like I just think it'd be easier because I had people. The place where it became really tricky was some people who were like right on the edge near the last assignment, and they're like, "Well, what's my grade so far?" And I'm like, "Do the math." And they're like, "I don't know, how does this work? How many points is this worth?" It's like it's all right there, but you know how that goes.
I had a teacher in high school who was like, "Don't ever ask them what your grade is. Everything has a number of points, and you get it back, and it has the number of points that you got. If you want to know what your grade is, keep track of it all and do the division."
I mean, did they tell you how many points there are total for the whole class, though?
No, you can just get your running thing. It sort of depended.
Oh, kind of a running average, yeah.
Yeah, we had like daily quizzes that.
And then the final is worth
sometimes
3,000
happens,
points.
sometimes
Yeah. It's like, yeah, and there will be a final in this class. Just kidding. There's some of this I'm tempted to do some kind of a final project, not for you guys definitely because we've already gone, but I'm a little tempted to do some kind of a final project paper or some kind of test. I don't know. It's like with programming classes, I like people to program. But I always get a little bit of pressure from people saying, you should be doing these stupid discussion things. And I'm like, no.
Ours have actually been pretty well. Like I like the discussion board.
Mm-hmm.
I don't really use them, but this is the first time I've actually used them. Pretty good for them.
Yeah, I like them for questions. I think that's good.
Yeah. Because then you don't have to answer the same question over and over again.
You'd think that would happen.
Well,
Until you get a lot of people who refuse to use the forums and think everything's a personal question and email me constantly all day.
I just email you constantly to see if you'll answer it.
Yeah. I haven't had any problem with you guys. I mean, it's in the Android class, I always get a couple people who, every question has to go over email. And they can't figure out where that line is. And it's like, and then of course, I've already answered it 3 times in various places on the forum, and they're like, well, I'm not following the forum. You should be following the forum. So,
Which is when you have the forum, but it's not open to ask questions. It's just
Yeah.
for discussions.
yeah, it's like,
I see that too.
Yeah, that's the worst.
it's like, no. It's like, and if you do have forums like that, you still need other forums to ask questions.
yeah.
It's like that's the way it should be, because I find that useful. And office hours. Office hours. I've had people taking me up this term. I never have that happen for the online classes. There's usually like 1 or 2 people every other week, and every other week there's nobody shows up. Okay. Any questions on the assignment or the stuff we've covered today? So one thing I will mention, and I'm going to mention it lightly. At javadude.com, underneath articles, if you can read all this tiny text, there is this Antler 3X tutorial. This is a set of videos.
You clicked on the wrong tiny.
I clicked on the wrong tiny text, didn't I? Yeah. So there's Antler 3, and then there's also Antler tutorial. So Antler tutorial, this is an old 2.0 tutorial. This is one that is just written, and he's got a billion pages on there. If you want a quick overview on the concepts, this works, but the syntax has changed a lot since these. The syntax I covered today is really what you're going to need to use for your assignment. The 3x one is a set of videos, so if it's something you're interested in, this gives you an introduction. Maybe someday I'll do a version 4, but I kind of doubt it because I'm leaning a lot more toward using Xtext, so I might do an Xtext tutorial at some point. What I was planning on doing with this was setting it up so that this had like an entire compiler. That was my plan for version 2. Then version 3 came out, and so I redid the version 2 stuff in version 3. Then version 4 came out. I'm like, damn it, I can't keep up with this crap. It's not as bad as not as bad as Android though. I mean, keeping up with Android, crazy stuff. So, and those of you who haven't taken the Android class, take it. It's fun. It's good stuff. I'm going to do that one face-to-face in the fall. And then the other 2 terms are online. Okay, any questions? Away with you. Off. Have a good week.
Does anyone
And happy 4th.
recommendations for classes without online discussions?